So welcome everybody to the week 2 discussion. Really, this is going to be a little bit more like a tutorial / extended Q&A because our goal for today is to get you rolling with all the stuff that we provided yesterday. I've been, on Piazza, I've seen that there's lots of discussion, lots of questions about it, it's working, it's not working, I'd like to do something different. And I want to say thank you to a number of the participants who've been answering questions. I do my best to answer as much as I can, but this with the day job, I've got to balance things. So thank you very much to everyone who can chip in, especially those of you who may be more familiar working with Raspberry Pis, with Linux, with Python. Please continue to provide aid to your fellow participants. I do want to emphasize off the bat that this is, again, an independent project. We are not going to handhold you through every step of the way. So when something happens like, I don't know how to import a Python module, I'm going to say, obviously, ask the question in Piazza, but, go do research, figure out why, put the error message into Stack Overflow, and odds are good you'll find an answer. So please, now there's fundamentally something wrong with, the OS image we've provided or instructions we've provided or whatnot, please let us know and we'll correct them. But I can tell you, having deployed that image, followed those instructions at least 5 or 6 times myself, fundamentally, there's nothing wrong with them. It's just a matter of maybe you're not exactly following the instructions in order. And I say that because I noticed somebody was commenting on trying to pull the Git repo after setting the static IP, which is not the way that was done in the instructions. That really should have an impact. But again, it's right. There's the instructions in order that they are for a reason. So if you don't know where to start, hopefully this will give you, what we'll go over today will give you an idea of where to start, because what we're going to be doing is basically looking at the GitHub repo, the image, and actually using the PIs with the reference code. So that's basically what this is. There are really no slides. It's all just sort of, you guys are going to observe what I'm going to do on the screen, and see what's going on there. So you guys can see, to see my VPN. All righty. So if we go to, and I apologize that's so tiny. I'll make it a little bit bigger for everybody. Hopefully that's a little bit more legible. So this is the org for piPact. And specifically, this is the reference code repo. All right. So let's go over what's inside the repo. So obviously at the front, there's a README. Okay. Any good repo should have a README. So, this is the reference instructor developed code for our BLE RSSI measurement collection. There are the requirements. We've only tested this with 3.73. I'm sure it will work with 3.8, but that's just, what comes default with the Raspberry Pi OS image, so we decided to leave it there. PyBlueZ, gatlib, NumPy, pandas, and PyYAML. There are the instructions for, let's just say, install the requirements. And again, this is a good example of what you would have to do your own research. So how do I install Python modules? Well, if you Google, how to install Python modules, you're probably going to come across, saying you're going to use pip, right? So again, the nature of an independent project is so that you can, that you're gonna have to do a lot of this sort of fill in the gaps for yourself, including, how I clone, so from Git and whatnot. Then there's usage. So this just goes how to use this, but we'll get into this more later. All this sort of detail stuff, but this is for your later reference. So we'll get into this later. But let's go over probably the real first step that you're going to take, which is how to set up your Pi, which is the Pi setup.markdown. So this README. Okay, so there are two options here. The two options are to use either a pre-configured image that we provided via this Google Drive link, okay? And it's a zip file, and you have to unzip the file, all right? Don't try to burn the zip to, don't try to burn the zip to the flash drive as is. So that said, if you're using the pre-configured image, okay, what you're going to need is a computer with micro SD card compatibility, some imaging software, something like Balena Etcher or WinDisk 32. You'll need the micro SD card we provided you, and presumptively a monitor, keyboard, and a mouse. There have been some discussion about wired versus wireless. We only recommend wired because some wireless mice require you to install drivers that come preloaded on at least Windows or Macs, but not necessarily on Linux. So you're just more likely to have success with the wired one, but by all means, you can try your wireless mouse. If they work, great. If they don't, then unfortunately, we're just not going to provide support about how to get your wireless mouse working on that Linux build. I'm not going to go find drivers for every single mouse that you may have. All right. So you're going to download the image onto your computer. It zipped up. It's a little under 4 gigs. So depending on the speed of your connection, that may take, some time. You're going to flash the image onto the micro SD card. All right. When you do this, I suggest you validate the image. It's just good to check that you did it right. And after you have, after you've done that, there was a good suggestion. I should add it to these instructions, that when you are done flashing the image onto the micro SD card, if you're on a Windows machine, at least, I can't comment necessarily for what happens on Macs. You'll want to, I don't have anything connected, but let me just connect something. So, what you'll want to do is, where are you? Oh, I need an SD card apparently. Okay. Well, normally on a Windows machine in this little in the taskbar, there'll be a little eject hardware, or you can do it from the computer in terms of ejecting the device that shows up. So I'm going to suggest you eject the SD card safely, just so it shuts down all the reading and writing, and so when you pull it, it doesn't get trapped or doesn't lose bytes. So after you have the micro SD card with the image flashed on there, you're going to connect your keyboard, mouse, and monitor, keyboard, and mouse to the Raspberry Pi. So keyboard and mouse presumably through USB, monitor through the micro HDMI cable that we've provided you to an HDMI compatible monitor, or if you have an adapter like HDMI to DisplayPort, HDMI to DVI, you can use that. That's no problem. Insert the micro SD card, make sure it's really slotted in there tightly, and make sure it's oriented the right way. You want the pins, the little metallic tabs on the SD card facing the board, okay? So if you hold the Raspberry Pi with the ports facing up, all the USB ports facing the ceiling, you're gonna insert the micro SD card so the little metallic pins are also facing the ceiling. Do not insert it upside down. You can cause damage. And then you're going to apply power to the Raspberry Pi, which is basically plug in the power supply. All right. When this happens, you're going to see a red light come on, and then you're going to see a green light sort of flash. The green light flashing is basically activity, is device activity, sort of like your hard drive indicator or a processor activity. Okay. Then what you want to do, if this is your first time booting it up, you'll want to change the username and password probably. The default Pi and Raspberry username and password respectively is default for everybody. So it's unsecure. Good practice, just make it something that you remember that you can use. You don't necessarily have to change Pi, but definitely change the password from Raspberry. You can also disable the Pi account if you want to secure your Raspberry Pi. It's just one last thing for to like loose end to leave aside. Then you want to connect your Raspberry Pi to your wireless network of choice. Be sure it's one you trust. Don't be, like anything else. Don't just connecting your device to some random network you find. Just your home network should be one you trust, but again, just one you trust. Then follow the instructions linked to just assign a stack IP. We've pre-populated the critical file you need to update with this text, but with these lines commented out. All right, they're commented out initially so that when you go and connect your Raspberry Pi to your wireless network, you just got automatically assigned an IP, and you'll be able to update packages and do all sorts of fun stuff, do all sorts of standard stuff like that. When you're ready to set the static IP, you're going to go into this file, dhcp.conf. Technically it's located /etc/ this file. And you're going to uncomment these 4 lines. Make sure you're doing the WLAN 0 interface. You want to assign whatever stack IP you want. It should be, generally speaking, it should be something like 192.168.something.something. All right. The first 2 are basically this. It should generally be the same domain as your network IP. The last 2 is just something unique, something that you don't expect your home network router to assign to other devices. Now, I don't know, on my network, I have on the order of maybe like a dozen or maybe a dozen and a half Wi-Fi devices attached. So I'm not expecting to get up into the hundreds of devices. So I've put a static IP on some Pis of 192.168.1.200, for example, right? Because I don't ever expect it to the automatic assignment to get up that far. All right. You then want to assign the router IP, which should be the same IP that your router has. And that's the same thing you put here. These instructions go over how you're going to do that. So they should be pretty clear. And I've done this repeatedly. This should work. For those of you who are having issues connecting, odds are good that you've accidentally set something up incorrectly, or your wireless network does not allow static IPs, all right? And that could be a problem, right? If some home network configurations, when they are unable to assign an IP to a device, they will block the device. Again, we can't debug all those situations, so you're going to have to do some research to figure out how to get around that. These instructions also tell you to reboot your Pi, so those settings take effect, but make sure you do that. This static IP will not take hold until you reboot the Pi. All right. So you want to test wireless access once you have this all set up. So from a computer with SSH capability, basically a computer, I am not moving. So apparently the stream is slowed down. Hopefully it'll catch up here in a second. But if you can hear me.
Fine, we can hear you just fine.
Okay, hear me, and hopefully you can still see the screen. A computer with SSH capability is a computer basically with an SSH client and a network connection. I'll talk about what the client is in a second. And using the stack IP you assigned previously, you should be able to connect to your Raspberry Pis following these instructions, specifically step 4 of these instructions. And once you're in, you should be able to execute commands on the Raspberry Pi remotely. All right, so these are the short instructions using the pre-configured image. For those of you who are interested or possibly having issues with the pre-configured image, we've provided also a from scratch setup, where you start from the OS image that the Raspberry Foundation provides, the vanilla image, all right, and how to configure it so it matches the pre-configured image. And so the first set of instructions about getting the vanilla OS image, obviously booting up the Pi, configuring Python, getting the reference code. You know, these are the things that the pre-configured image did for you already. All right, you're just basically repeating the steps that we've done already. After that, it all looks the same. Okay, so not a lot of extra work, but it's stuff you have to do. And if you're not feeling comfortable, we recommend you use the pre-configured image. All right. So at this point, I'm just going to quickly scan the Q&A to see if there are any directly related questions on this section. Would it possible to remotely set it up using my MacBook? So there's an ongoing discussion about headless config on the Raspberry Pis. Headless refers to being able to configure the Raspberry Pis without a monitor, okay? You can do a headless config so that you automatically, after you deploy the image onto the SD card, you can load up a Wi-Fi setup so it connects to your network. And then there are a number of ways for you to find the IP of the Pi on your network. And this would be the IP that your home network assigns to the Pi. Once you find that, you could SSH into it from a MacBook or a Windows device or whatever, and you could set the IPs and make all these configuration changes and then reboot. But again, as I stated previously, if you make any of those changes and you make them incorrectly, you will not be able to SSH back into your device because it's not necessarily going to have the stack IP you assigned to it. It's not necessarily going to connect to the network in the way it previously had. At which point, your only recourse is to re-image the system, okay? Because I don't believe, to my knowledge, you can overwrite this dhcp.conf file via headless config files. I could be wrong, but I highly encourage you to reference a discussion that's going on Piazza and do your own research. Are we installing those packages on our device or on the Raspberry Pis? This is on the Raspberry Pis. There's nothing you need to do on your laptop or home computer. Your laptop or home computer is merely the gateway to the Pis. It is the interface by which you're going to interact with the Pis. All the computation, all the packages are on the Pi itself. All right. Gatlib should be imported on the Pi, not the PC, correct? Yes, absolutely. Gatlib should be imported on the Pi and not the PC. There's nothing you need to explicitly do on your PC, okay? You can do all of the project development on the Raspberry Pi. Anything you do on the PC is a matter of convenience and preference with respect to, I would like to work on the data I collected on the Raspberry Pi. I would like to write my code on my computer because I prefer the IDE on my computer, IDE standing for Integrated Development Environment. So if you have, if you like Visual Code, if you like PyCharm, if you like Notepad++, whatever you prefer, you can do, you can use it that way, all right? I'm not sure why when I connect my Raspberry Pi to the monitor, no display shows up. It's getting powered because the lights will flash, but the display doesn't show. I believe I followed all the steps. So my first recommendation, and I think there's an ongoing discussion about this in Piazza as well. Obviously, the first recommendation is to check the cables. Make sure you plug in and this may be a little bit of an oversight, plug in the HDMI cable into the HDMI port that is the furthest closest to the USB-C connector, closest to the power connector, right? That's the one it uses by default. Use that one. Then make sure your monitor is set to HDMI, all right? Sometimes they don't always auto detect depending on the power, and sometimes they require power cycling. After that, if you're still having issues, I suggest you go to the from scratch instructions, deploy the vanilla OS image, and see if that doesn't bring up the image. And test it on both your Pis. Don't just use one Pi. If you're having issues with one Pi, after trying the OS image, trying everything else I've recommended, then there's a good chance that that Pi is defective, all right? If both Pis are problematic, then more than likely something's wrong. Your monitor is incompatible for some reason, though that'd be highly unlikely. With the /24, the first 3 octets of the network, only the last one can they assign. Thank you. I appreciate that insight. This gentleman, again, I don't mention names on the live streams or on these videos just for privacy sake. But this gentleman has been extremely helpful on the Piazza, so lots of credit goes to him. He's been very helpful. Thank you very much. What does static IP mean? Static IP refers to the fact that, so again, in typical IP4, IP6, so this IP stands for Internet Protocol. Basically, John is an LL employee. Wow. All right. Thank you, sir. Definitely more savvy on the various details. So I can mention him. It's okay. So John Orthoffer, thank you very much. Typical Internet Protocol configuration, at least as far as your home network is assigned, the router is the brains of your network. It's basically, right, think of your router as a postman in a lot of ways. It sends and receives information like a postman sends and receives mail, all right? The one thing the postman doesn't do that your router does is it assigns addresses, all right, typically. Basically, every device on your network is assigned an address, right? Because it needs to know to whom is this piece of information intended and from whom did this piece of information come from. Typically, it automatically assigns those. So it starts with those first 3 octets, 192.168.1 or whatever it may be, and then automatically increments the last octet based on the number of devices on their network. So that's called dynamic or automatic assignment. A static IP is basically saying that I want to fix what that address is because I want to know what it is all the time. Why we're doing it is basically you will need to know that IP, or it's a lot easier to use that IP to access your Pis. And if it's changing every time you necessarily power on your Pis, just to give you an example, let's say you power on Raspberry Pi A first one day and Raspberry Pi B second the same day. You know, A may get an address that ends in 10 and B may get an address that ends in 11. But then when you go and boot it up another day and you switch the order in which you boot them up, they may get different numbers, right? So you may not be, and that might not be meaningful necessarily to what we're doing, but depending on how many devices are on your network at any given time, that address may change. And so static IPs just generally help us to be more consistent. It makes life easier. Can you go further how the Raspberry Pis will help in our independent project? Well, the Raspberry Pis are a collection platform, right? We need Bluetooth devices. They are the Bluetooth devices you'll be using. The Bluetooth devices to advertise the beacons and the Bluetooth devices to collect the beacon information. And I'll show you how that happens now or shortly. Which way would you recommend? I assume by which way you're referring to the pre-configured versus the from scratch. I would recommend pre-configured just from a simplicity, sort of reliability standpoint. But you know, I like to do things. I like to know the whole process. So it just depends on where you want to spend your effort. I only recommend pre-configured because it's less work. You need a Linux box so you can mount an external 3. Oh, there we go. Thank you very much again, John. How do we remotely access the Pi off our personal computers? I will show you in a second. I remember there's some discussion about VNC viewer. How would we be able to use the same monitor for both the device and the Pi? So if you're using a VNC viewer, it's a separate app, right? It basically runs in a window, depending on the nature of the VNC viewer. So you can VNC on one half of your screen and then the terminal and then the regular sort of computer interface on the other. You can't run the monitor for both your same device and the Pi because it's receiving the display from one device. That's just not an option. How do you upload code written on your laptop to RPi through SSH efficiently? So SCP is a great way to do it. You can download any number of secure file transfer protocols like Core FTP or FileZilla, FileZilla for Mac. There's any number of secure FTP clients. SCP is a good option though. Should both Pis be configured, and do we assign the same stack IPs? No. Like if you like a house, you don't want to have the same address for 2 different houses. You do not know where to send the mail then, right? Each house needs its own unique address. Each Raspberry Pi needs its own unique address. All right, I'm going to answer 2 or 3 more, and then I'm going to get to showing you how things actually work. So once we finish configuring the Raspberry Pis, we don't need the monitor, mouse, or keyboard anymore. That is correct. You only need it to configure the Raspberry Pis, and you only need it as if the headless config doesn't really work for you. But again, we've tried to, the headless config is a little bit of, it's not complicated, but it's not necessarily simple either. And we try to go with the approach that we feel most people can sort of just plug things in and make it work. And I know it's created some extra onus on certain folks, but we have to pick a route and we had to go with it. So apologies if we've left you a little bit short, holding the short end of the stick, but we'll try to get you through this. Is it possible that ejecting an SD card from the computer properly would cause the Pi not being able to start? There is an outside chance that the image, the SD card has been a little bit, well, hopefully only the data is corrupted and you can reflash the drive. And the worst case, the card might be corrupted, at which point you'll need a new card. This is rare, but there's a chance. To sync code between 2 machines, you can use Git. Yep, make a repo on the Pi and check it on the PC and Mac and push it back to the Pi. Absolutely. You can make your own repos. Git comes installed in as part of the standard Linux distro. So even with the stack IP configured, as long as you're connected to your home network, you should be able to get up and down between the Pis using the repo as a central point. If we don't have a monitor keyboard, how do I suggest I set up the Pi? So I would highly suggest you look into the headless config, do some research about how it does, ask some questions in the Piazza, and hope that between the instructors and your fellow participants, we can find a path forward. Can we use other Bluetooth devices such as mobile phone to collect some data in addition to Pis? Absolutely. I believe I answered this on Friday. You can absolutely collect data on other devices, whether it be about Pis collecting information about devices that aren't Pis, or devices that aren't Pis collecting data about the Pis themselves. Any mixture is fine. The only reason we provided you Pis is that they provide a unified and uniform platform for both halves of the equation. So with absolute certainty what you're working with, right? So there's no uncertainty there. Okay, so with that, we are going to get to how does this actually work. So I'm working on my personal computer upstairs in my office, and my Raspberry Pis are downstairs in my living room, okay? So they're on my home network, all right? So what I'm gonna do is I'm going to SSH into the Pis, all right, first. So I use Windows, as you can probably tell from my screen. And I use, and you guys get to see that I'm a gamer too, if you spotted that closely enough. I use a client called PuTTY, and I apologize for the size of this. All right. Let's see if I can. Well, I'll leave it this way. So you may have to squint a little bit. But PuTTY is a pretty standard SSH client for Windows, and it's even available on other platforms, but for Windows. But SSH is built directly into Mac OS X and is also obviously directly built into Linux. But Windows needs a separate SSH client. It's also available on Windows 10 after a certain release. You can use the built-in one. I just prefer PuTTY because I'm familiar with it. So the bottom line is, depending on your SSH client, it's going to basically say, I need to know the address of the device you want to connect to, okay? So the device, the address of the device I want to connect to is the address of the pies, okay? So it is that static IP you assigned. And so for the pies I've configured, I've assigned one of my devices as 192.168.1.200, okay? That's the static IP I assigned to one of my Raspberry Pis. And so I'm going to connect to it. And you can save this profile, et cetera, okay? So, and I'm going to open this up, and I'm going to, if you know, I'm going to just change some settings here so everybody can actually read the text a little bit more legibly, right? That should be a little bit more legible. Okay, so up here in this is the PuTTY terminal, all right, or the SSH terminal. And the first thing it's going to do is ask me to log in. So I didn't change the username. I left it as pi, but I did change the password. So I'm going to enter that updated password. Hopefully I'll get it right the first time. And there, I logged in. So this is what the terminal looks like, whether you SSH into the Raspberry Pi or you start a terminal on the desktop of the Raspberry Pi when you're connected via monitor. But for those of you familiar with Unix or Linux terminal, this should look very familiar. And for those of you who are not familiar, you're going to want to go and get some, do some quick reading on how to navigate Unix and Linux terminals. I'll give you a real quick rundown of some basic commands that you'll need to know. So the first one you're going to want to know is change directory. All right, so that's CD, change directory. All right, that is probably one of the most ubiquitous ones you want to know. But you also want to know list structure, LS, because this in a lot of ways tells you where you're at currently, what's around you. So LS lists everything that is in the current directory you're in. So you can see here that I have some very standard folders, all right, bookshelf, documents, music, blah, blah, blah. But most importantly, I have reference code. This is the reference code I downloaded from the GitHub, all right? And specifically, this is where it's going to be on, this is where it's going to be located on the pre-configured image. This is part of what comes in that pre-configured image. If you want to know where we're at right now, PWD, print working directory. We are currently in home/pi. This is the home directory when you log in, right? So we're in the /home/pi. So I want to go into the reference code. So I'm going to change the directory, CD reference code. I can do tab autocomplete, and that puts me in the directory. What I print here is going to look a little different than what you look. But if you look at this, you'll see a lot of the files that were part of the repo. So let's just show that. So I'm going to go back to the reference code, and you can see here, that I have the license file, the README, the piPact.py, the core module, the config file or config YAML, and the setup file. I have some extra files here that get generated specifically the PyCache. This is generated when Python basically, Python's not a compilable language, but it does cache some things. So this gets created when you run your code. But I have some log files that will go over what those mean exactly. And then some output files that we'll also go over. But this is what is in that reference code, the same stuff that's in the repo, all right? So this is 1/2 of the 2 pi's. This is 1 pi. So great, what next? What do I do next? So let's go back to remember our basic premise here. We're using 2 pi's. 1 pi is going to advertise beacons, and 1 pi is going to scan for beacons. So I want to call the pi that I've just logged into, this advertiser pi, is going to advertise beacons. So I need to now log into the other pi. So I'm going to open another SSH session, all right? Or in my case, a putty session. I'm going to log into the other pi. And this pi, I assigned a unique, another stack IP. This one is 192.168.1.201. The first one was .200. This one is .201. All right. So I log into that. Again, let me change this so it just looks a little different, or a little bit more legible at the very least. I'm going to log in. Again, I didn't change the username, but I changed the password. And I typed it wrong, so let me try that again. All right, and I logged into the second pi. All right, and you can tell, and now if I look at where I'm at, same setup, it looks the same. And I can go into that same reference code and it looks very similar, right? Obviously, you guys can tell that I've been testing things on the pies that I have, all right? But the pi, at least when I look at the screen, and I hope it's the same, it's not mirroring it, but the pi that I'm highlighting now, this is going to be the scanner pi. This pi is the advertiser pi. So this is where we're now going to get into how the reference code actually works, and how if you're going to write your own code, is like you write your own software, the basic functionality we expect you to emulate so that you can do data collections. But the main minimum we're going to get to here is how to use the reference code to collect data. All right. So here is how you do that. So the first thing you need to do for everybody, and this is sort of a Python 101 stage, is you should consult the help of any, if it's a well-written piece of Python code, it should have help associated with it. I generally do, I recommend almost everything you do on this project related to the collection software include the use of sudo. All right, sudo is a way for you to get super user access, basically to read and write things, to override some default permissions. It's not necessary to get like help, for example, but it is often necessary to access the Bluetooth devices that are actually on the Raspberry Pi and to easily write output files. So I recommend you generally do sudo in front of most of your Python execution, but you can play around with it. There won't really be any harm, no foul. You just may encounter errors, particularly permission denied errors. So I'm going to do sudo, and then I'm going to invoke the Python 3 interpreter. Make sure it's the Python 3 interpreter, right? Don't just do Python. Python by itself is, at least on the default Raspberry Pi deployment, is just Python 2. We want Python 3. So Python 3, and then you reference the module you want to run, or the module which generally has a script or main method execution. And again, there's a sort of Python 101. You should Google it, research it, Stack Overflow it, learn about how you write modules with default execution scripts. But if you just run this, all right, you're going to get first an error. It's going to print what looks like, all the options, and it's going to say there's one of the arguments is required, that you either specify it's an advertiser or you specify it's a scanner. But you also have a help option. So I'm going to specify -h, sudo python3 pipact.py-h. And when I do this, I will get a little help message that sort of tells you what this module is all about. So this is the BLE, beacon advertiser or scanner. Command line arguments will override their corresponding value in the configuration file if specified. And then here are all the arguments, all right? There are a number of optional arguments. Some of them are not necessarily optional. Like you have to be advertiser scanner, but this is how it's written. And so there's a whole bunch of things, and we'll try to get through all these. But let's get to how to actually run this. All right, so the most default way to run this, all right, and a useful command for Unix is clear. Just clears the screen so that you can have a nice fresh slate to look at. So I'm gonna run this, all right? And here's where you kind of need to refer back to, you'll want to be referring back to this README, because this README, everything that I'm doing here is captured in this README. From how to configure the code, to how to start the advertiser, how to stop the advertiser, how to start the scanner, how to stop the scanner. I'm just gonna go through an example of how to do that live, but all of that is captured in this README that's on the GitHub. All right. So again, this pi is my advertiser pi. So I want to specify -a to tell it's the advertiser. Then what I want to do is I want to put an ampersand at the end of this. The reason you want to put an ampersand at the end of this is it runs the code in the background. It returns control of the terminal to you. This is important when you're working in SSH, generally speaking, because unless you're using, I'm sorry, I'm totally forgetting the multi-window option. There's a way basically to have multiple windows even via the terminal, but this is an even simpler way of pulling this off and appropriate for what we're doing. You run the code in the background. So if I hit enter here, what basically happens is it reports that I'm running this under process 722, and suddenly a number of messages start to get to print. These are messages that are being printed by the code itself. It's saying that you selected the beacon advertiser mode, it started the beacon advertiser, and it's starting the beacon advertiser with timeout none. Now, what these messages mean is up to you to go inspect in the code. The code is documented and it explains it. I'm not going to explain it now. All right. If you hit enter again, you'll actually see that the code is still running in the background, but I have control of the terminal again. So the advertiser is running. It is just broadcasting beacons. Now, if we go over to the other Raspberry Pi, the scanner Raspberry Pi, and I run the same code, but instead of advertising, I want to scan with this one. All right, so I'm going to put -s for scan, and again, I'm going to put that ampersand so that it runs in the background. You'll see a very similar process occurs. A message, I see that it's running on process 699 on this Pi, and I see some messages, very similar, but a key distinction. It is running a scanner mode. All right, so both these Pis are now running. One is advertising and one is scanning. Okay, that being the case, right? What happens now? Well, the scanner is listening for the advertisements. I'd like to, and I want to see them. I want to see what's happening. Well, the way the code is written right now, it only outputs the information after it's done scanning. So how do I stop it from scanning? So you will see in the same folder, there's now a file that was generated called scanner control. Scanner control is just a file that the code generates that basically has a 1 or a 0 in it. It's basically a flag that tells the scanner to stop. All right. So if you put anything but a 0 in that file, it will stop the scanner. And the easiest way to do that is to use a command called echo. Echo is just a way for you to echo a set of a string, a number, or whatever into a file. So if you do echo, I generally, as simple as possible, 1 into scanner control, right? And again, all of this is captured in the README on the GitHub. You'll see suddenly there's a message that gets printed that says stopping beacon scanner. And now the scanner is done. It's done. And we have a report back from the Pi itself that said, I finished this command. So the scanner is done. So since we're not scanning anymore, I might as well stop the advertiser. And the advertiser works in a very similar fashion. Instead of a scanner control, it creates an advertiser control, but it works in the same fashion. All I'm going to do is I'm going to put in 1 into that advertiser control. All right. And I'm going to get a very similar message. It just says that it is stopping the beacon advertiser. Congrats. So what is the output of all this, right? So first we're going to look at the advertiser. Did anything change? Well, I got some messages, great. But did I get any more files? Well, if you look at this, no. I got no new files, all right? If you look at these dates, right? Nothing has changed recently, all right? Definitely nothing after 1600, all right? After we started this discussion. However, on the scanner, the device that was supposed to be receiving information and logging it, something has changed. Specifically, it has created a log, all right? A scan file, a scan CSV, all right? And it creates one that is timestamped, that tells you when that scan started, right? So 16, so military time, 4 o'clock or 4 p.m. at 48 minutes and 45 seconds. So what's in this file? What is in this file is the data you're going to be using. So I maximize the scanner pi. So that's all we're seeing now because we want to have maximum real estate for this. So if we just go look at what is in that file, you will see that it is a comma separated value file. So for those, so you can look that up. It's a very simple way to put a spreadsheet together where the top row is the headers. So we know what scan. Again, read the code, read the documentation. It'll explain what all these mean. We have a scan number, an address, a timestamp, a UUID, major, minor, TX power, RSSI. And then we have a number of entries. So it turns out that in that duration we scanned 100 times, 0 to 99 times. And it turns out that when we scanned, we only saw one device, it turns out. One device that has this address. All right? So how do I tell that this is the address of the Bluetooth device that that I'm actually looking at, that this Pi is actually doing? Well, Google to the rescue. So let's see, Linux, find Bluetooth device address, right? And if you look at this, you'll find you really only need this. You can see here that this is the same address that got reported here. All right. If there are other devices broadcasting beacons. And I want to emphasize one thing. This code is written to find beacons. You can modify or update the code to detect generic Bluetooth emissions, but this code is designed to detect beacons. And here I am at home. Again, nobody really generates beacons unless they're using it for a specific purpose. So there's only one beacon, the beacon I created on the Raspberry Pi. Now, we'll quickly go over what the rest of these fields mean, okay? So again, the address of the Bluetooth device here, the timestamp at which the scan was done. So you can see here that if you look at time, this is done every 1 second. I scan every 1 second. Then, plus some significant digits for fractions of a second. Then here, this is UUID, unique user identification number, right? This is just something that gets the beacon as automatically generated for itself, or you can specify via the config file to uniquely identify itself. And it doesn't have to be this long thing. It can be something shorter. Then we have major and minor. Major and minor are just additional identifiers. They're ways for you to say, I actually want to assign multiple things the same UID because they're all part of the same system, but each individual beacon is unique from each other. So think of it as an additional layer of uniqueness or additional level of identifier. You can specify unique UUIDs, you can specify unique major values and unique minor values. And they're just used for identification purposes. They don't have any impact on what is being transmitted or who's transmitting what. They're just used for identification. Then we have TX power. This is the TX power that the beacon is advertising that it is broadcasting at. Now, this is one of the great sort of unknowns of beacons, because depending on the implementation of the beacon, the TX power value can vary widely. So on the Raspberry Pis, they go from, I believe, -40 to 1, where -40 is the lowest TX power and 1 is maximum TX power, and is just a decibel value scale. However, on other devices, it can go from 0 to 100. And so it is not necessarily a reliable number to reference in saying, like, I know this device is transmitting at this power level, because it's not consistent across devices. The last value is the value you're most interested in, the RSSI value. This is reported on the Raspberry Pis in dBm or dB milliwatts. This is 10 times log 10 of how many milliwatts of power of received signal that the Raspberry Pi that is doing the scanning receives, right? So 10 dB, or so minus 48 dBm is 10 raised to the minus 4.8 times 10 to the minus third watts. It's a very small value, you know, it's in the microwatts, all right? So this tells you the signal strength. So as you move the Pis further and closer apart or put obstructions between them, this is the value you expect to change and the value you want to really be paying attention to. And you can even see here, even in the case where the Pis, which are downstairs on my living room table, not moving, that the value changes. It is not steady state. It is not consistent. There are fluctuations happening. They are generally in a sort of a nominal range between, you know, minus 55 to minus 45, but they're varying within that range. And that is part of, you know, the challenge of this task, that even when things are completely steady state where you don't expect things to change, that they do vary. Okay, I see a correction, the minus 40 to 4. Okay, so that's a correction. It goes minus 40 to 4. I think I just chose 1 because it's a nice number. But this is something for you guys to play with. All right. So in the last few minutes, as I overwrite my own file, I want to quickly go over how you guys are going to configure your beacons and configure your scanners via the configuration file. All right. And we'll have lots more follow-up on Piazza. And again, I refer you to the GitHub instructions. They will be, sorry, I just need to hide this. These will be extremely useful, right? They'll show you exactly how to do all this stuff. But we're going to talk real quickly about this configuration file that's provided. All right. So YAMLs. YAMLs are a format of configuration files. It's a markup language, basically. So if you look at the configuration YAML file, so piPact.config.yaml, which is the default one we provided you. This is the same one we've provided you on the GitHub that we talk about on the GitHub README. So there are 3 major sections. There's one that is for the advertiser, one that's for the scanner, and then one is for logging. And I guess I didn't talk about the logging, but that's a little bit of an extra debug thing. So we won't get into that right now. So the control file, the advertiser specifies a number of things. First of all, it specifies the control file you can use to start or stop, or to stop the advertiser. So by default, it's advertiser control. All right. You can change it to something else. So if you have multiple Raspberry Pis and you just want to have unique files for each one, or you want to distinguish that for whatever reason, these files, you can change that value. There's a timeout. So instead of stopping it via the configuration file, you can stop it via a timeout. Okay. So I only want to run the advertiser for 20 seconds. When you specify this value, it overrides if you reach the reach the timeout before you pass a stop flag via the control file, it's going to stop. Then the rest of these values are the ones we talked about. The UID, which you get to specify. If you leave it blank, the code will automatically populate something. The major value, the minor value, the TX power, again, your choice. And then the interval at which you are doing the advertisement. So in this case, how often you advertise at. There's a lower limit on this, but we found that 200 milliseconds is a nice balance between power drain and heating up the Raspberry Pi and actually broadcasting the beacon often enough. In the scanner section, they're very similar settings. The control file again, so stopping the scanner. The scan prefix, which is basically that prefix for the output CSV file. So the CSV files are automatically, they take the prefix and automatically append the timestamp, just so you guys never overwrite data. I know the pain of overwriting data. That's why we're doing it this way, right? Specify the prefix so that you know what it is. So you could specify the prefix to correspond to the type of experiment what you're doing. So for example, I'm doing an indoor experiment. So the prefix might be indoor experiment. And so when I do that experiment, all the data that gets generated has indoor experiment plus the timestamp. And then when I go do an outdoor experiment, I should change the prefix to be outdoor experiment so that it doesn't clobber the indoor experiment data. Then we have timeout again. Maybe I only want to scan for 20 seconds. How often do I want to revisit? There is a lower bound on the revisit interval, and this is due to the limitations of gatlib and PyBlueZ. At most, they can scan at 1 hertz. That is the fastest they can scan at. So we are actually advertising faster than we're scanning. But you want to sort of, that's a better place to be than the opposite. And then there's actually some filter options. Basically, if you're detecting lots of devices, you can add filters so that you can remove things, so that I can only get the data from my Pi, or I don't care about things that are so weak. You know, there may be a Bluetooth device broadcasting down the street, and it's getting RSSI values of a minus 110 dBm, and I don't want to see those, so I can filter by RSSI. You guys are going to need to read the code to understand how this works. I'm not going to go into how that does now. All right. All this again is on the GitHub README. The last thing I'm going to go over real quick is the logs that get stored. This is distinct. These are the logs that are used for debugging purposes. So you can see here that there's a piPact.log that gets generated, and it actually automatically has what's called a time rotating handle, so you don't accidentally create log files of unnecessary size. But if you look in this log, it actually writes all the things that that the code is generating, including the stuff that got printed to screen, which are these info messages, along with a whole bunch of debug messages, so you can tell what's going on. So you can see for this, the log contains more information than what you saw on screen. So I can actually tell exactly how the beacon was configured, how the scanner was configured, or what scanner configuration was, what things were sort of used by default, and then the fact that it actually did 99 scans. All right. So this is a way for you to confirm what's actually going on. The same thing applies. The same thing is true over here on the advertiser. You can see a little bit more information, saying that, look, I actually am advertising with this UUID because, you didn't specify what it was. And that, I got a few things, that there was a flag that was set. So there's obviously less information here because the advertiser is sort of doing things by default. All right, we actually went over the hour, but this is really important stuff, and I'm glad we're recording it because I hope you'll refer to the video as needed, and of course the README. So I'm going to answer the last few questions. When I ran the code that said it should have no timeout, it defaulted to 20-second timeout. How do I change that? Okay, so if you look at the help file, if you look at the way it's run, when you specify, so when I ran it this way, right? When I ran it with, when I ran it with just this, I didn't specify the config file, all right? If you follow the instructions on the website, you'll see actually I am specifying the config file. When I specify the config file, it actually references now that configuration file that you are pointing to, and you can see here that it actually does have a timeout specified. So if I let this run, it'll time out after 20 seconds. At the same time, I can actually just prematurely stop it. I don't have to wait for the 20 seconds. So that's your thing. If you run it without the configuration being explicitly specified, it defaults to the defaults that are written into the code itself, which you can find if you go into the code. Right here, you can find them all specified at the top here. You can see that timeout is none. But if you specify an external configuration file, it's going to use that. So these are sort of the multiple levels of control / safety checking as written into the code. Okay, last question. How do you set a manual IP address? So by manual, I assume you refer to static IP. Go away, Windows Defender. Refer to the instructions. Refer to the pi setup.readme, the markdown that's on the GitHub. All right. And with that, I've almost lost my voice. And with that, we're going to just close the session. Again, keep asking questions in Piazza. your colleagues, your participants, and also I want to call out to John again, John Orthoffer, who's a Lincoln staff member, for being extremely helpful. He's been answering a lot of questions. Obviously has a lot of knowledge that not only that I share, but I don't have. So I would say we're going to start treating him as a de facto instructor as well, definitely as far as Piazza and the Q&A is concerned. But don't hesitate. We'll do our best to get everyone to the finish line as far as using the devices, using configuration. So with that, I declare the session closed, and I look forward to